Okay, so I will be going over paper 2, question number 2. So here the question asks to identify the slope of the demand function given above. We're given the equation of QD equals 420 minus 30p. In order to solve this question, you need to understand the equation of QD. So QD stands for the quantity demanded for a good. Then there's usually an A variable, which stands for the quantity demanded of a good if the price were to be set at 0. Then we have the variable of B, which stands for the slope of the demand curve, which shows how responsive the quantity demanded is to a change in price. And then we have P, the P variable, which shows the price of a good. So here, from what we can see here, our slope would be negative 30. All right, for part B, we are asked to calculate the price at which the monthly quantity demanded would be 210 units. So if we use the original equation we're given 420 minus 30 times P. So we just plug in 210 for the quantity demanded, and we subtract 420 from both sides, essentially getting negative 210 is equal to negative 30p. Then we divide negative 30 to both sides, and we end up with $7 as our price. For this, it's really important to not forget your units, and it's very important for the IB to show your work, because if you don't show your work and just plug in all your work in a calculator without writing it down, you will lose points. So show your work. Okay, next question here we have is 60 units. We are given that the quantity demanded would be 60 units. So of course we go back to our original equation. Quantity demanded is equal to 420 minus 30p. We plug in 60 for quantity demanded, and we do some simple algebra, and so we subtract negative 420 from both sides, leaving us with negative 360 is equal to negative 30p. We divide negative 30 by both sides, and we end up with $12 as our price. And again, don't forget units and don't forget to show your work. Now we can move on to the second piece of the worksheet, and here we are asked to label the axes on the following grid. So this is something that you should naturally know. So as we can see, it's a 1 mark. So here P would be in your y-axis and Q would be on your x-axis as usual. So in order to construct the demand curve for good X on the following grid, which is asked, the easiest way to do this would be to plot your initial and ending points. So find the P and the Q. So to do that, what we end up doing is you can use 2 different equations. So here we have your quantity demanded equation that you were given, and in order to find your quantity demanded, if it were to be 0, you plug it in and you end up getting your price of $14, which basically means that there would be a quantity demanded of 0 if your price were to be 14. Then to get this point over here, we can plug in 0 as your price, which means that at a price of 0, your quantity demanded ends up being 420 once you do the algebra. So here, if you have your ending and starting point here and here, you can use a ruler or a pencil to connect both points, which saves you a lot of time on your exam, which is really important. And of course, make sure to label your demand curve. Labeling is very important for the IB. All right. Okay, so now we're gonna do question 2. And the question is, outline why the position of the demand curve will change if the demand function changes to QD equals 500 minus 30p. And originally, our original equation was QD equals 400 minus 30P. And so what we're seeing is that our A variable is what's being changed. So it's going from 420 to 500. And it's changing by 80 units. And due to an increase in quantity demanded, because of that, this shows that the demand curve will shift to the right. Now, on the next part, we are being asked to outline how the steepness of the demand curve will change if the demand function changes to QD equals 420 minus 40P. So initially, we had our B variable be negative 30, and now it's negative 40. So from what we can see here is that there is an increase in your B variable is larger, and from your B variable, we're getting that your quantity demanded would be higher. Therefore, the curve would be flatter. And to explain a little bit more in depth of this, since there's an increase in the B variable, so it's higher, this means that there's a greater responsiveness to the change in price. And because of that, from that definition on its own, we know that it is more elastic. And for something, when something is more elastic, it is flatter. It's more flatter than it is steeper. So from that, we can get that the demand curve would be flatter. All right, next question. Okay, so now we're gonna go to the next part, which is calculating PED. So here it's asked to calculate the PED of demand for good A, which we have here. So we're gonna look at good A. When the price falls between January 14th and February 14th. So here and here. So all we're looking at is this section. Don't worry about any other section. So essentially you need to understand what PED shows. So PED is meant to show the responsiveness, the level of responsiveness if there's in the quantity demanded, if there's a change in price. So you need to memorize the equation of PED, which is the percentage change in quantity demanded over the percentage change in price. So from what we see here, we can start off with the percentage change in the quantity demanded. So here it's going from January 2014 to February 2014. So initially it was 160 and it moved to 220. So it's really important for you to know the equation when you're finding percentage change, to use the equation of the new amount minus the old amount over the old amount as well, and times 100 to get your percentage. So here your new amount, which would be your new quantity demanded in February 2014, would be 220, minus your old amount, which was 160, over 160, which is your old amount, times 100. And when you calculate that, you should get 37.5. Now, to calculate the percentage change in price, you have to look at the price that's over here in your table. So it goes from 8 to 6. And as we said before, you use your new price, that being 6, minus your old price, that being 8, over your old price, that being 8. So you divide that, and then you multiply it by 100 to get negative 25. After that, you divide the percentage change in QD over the percentage change in price, and you should get negative 1.5 as your answer. Okay, Now, for the second part, we're asked to calculate the cross-elasticity of demand between good A and good B when the price of good A falls between January 2014 and February 2014. So, XED definition is that the responsiveness, it measures the responsiveness of consumers' demand of one good to a change in price of a related good. So from what we're given, here is an equation of XED that we are meant to follow. So it's a percentage change in QD of good X over the percentage change in price of good Y. And the thing that's really important that messed me up when I was initially doing this was that I looked at it in terms of good A and good B. So I automatically assumed that the good A that's being talked about in this problem would be that I would have to calculate its quantity demanded, but that was not true. What the question's asking is that to calculate the XED based on the change in price of good A. So your good A is actually what would be on the bottom, which would be your change in the percentage change in price, and then you would be looking at your good B for the top of it, which is your percentage change in quantity demanded. So it's really important that you don't mess these up and make sure what it is that you're being given. Because when I initially did it, I messed up and I got an answer of 0, which is definitely not correct. So once you figure out where to put your good A and your good B and which one you're looking at, we can begin to calculate. So first we'll be looking at good B and its percentage change in quantity demanded. So over here we see that it goes from 200 initially from 200 to 190. And because of that, we get that our new quantity demanded is 190 minus your old quantity demanded of 200 over 200 times 100. And you get -5. Now, after that, you need to calculate the percentage change in P of good A, which would be 6 minus 8 over 8 times 100 is equal to -25. So you divide -5 and -25. And here what's really important is that in XED, the sign in which you get your answer is really, really important. So because you end up getting a value of 0.2 after you divide, this means that both good A and good B are both substitute. If it were to be negative, that would mean that they are both complements to one another. And perhaps if XED were to be equal to 0, that would mean that they were to be unrelated goods, but that is not the case in this problem. Okay, so now for this part, we are asked to calculate the cross-elasticity of demand between good A and good C when the price of good A falls between 2014 and February 2014. So for this, we need to refer back to our table that we had initially. We need to know, again, the equation for XED, which is the percentage change in quantity demanded for good X over the percentage change in price for good Y. So for this, we need to identify which is going to be our what good is it that we're gonna plug in for X and Y. So what we're being given is that in the question is that there is a change in the price of good A. Therefore, when we plug it into the equation, we put it in our denominator for this equation, good A, and then above it would be good C. So for good C, to calculate the quantity demanded, we do the new quantity demanded minus the old over the old. Oh, not minus the old. divided by the 100. So now we're going to calculate the cross elasticity of demand between good A and good C when the price of good A falls between January 2014 and February 2014. So we'll be looking at good A and good C. So we need to use our XED equation, and what we're being given is that the price of good is falling, of good A is what's falling. So we can calculate the percentage change in price for good A. Therefore, meaning that our good C would be on top of for our equation. So for good C, we get our new minus our old over our old quantity demanded, which is 150 minus 100 divided by 100 times 100 in order to get 50. For good A, to calculate the change in percentage of the price, we get here, which would be that A goes from a price of 8 to 6. Therefore, we get 6 minus A over A times 100 is equal to negative 25. And from that, we divide 50 divided by negative 25, and we get negative 2. It's really important that you have the negative, because the negative for XED means that both goods are complements to one another. So using your answers to part E, explain the relationship between good A and good B, and between good A and good C. So from what we saw from the previous questions, we saw that XED for good A and good B is 0.2, meaning that they are substitutes since the sign for XED is positive. So this means that the price of one and the quantity demanded of the other good move in the same direction. Then for our good A and good C, we found that our XED is equal to negative 2, meaning that because it is negative, both goods are complements to one another. Since they are complements, this means that as the price of one and the quantity of the other move, they end up moving in opposite direction. Okay, so for our last part of the question, good J and good D are both produced in Zestria. The PED for good J is a primary commodity, which is negative 0.2. The PED for good K, a manufactured good, is negative 2.3. Explain 2 reasons why the demand for products such as good K tend to be relatively price elastic compared to the demand for products such as good J. So here is what it is that we know based on the question. We know that good J is a primary commodity, and because it is a primary commodity, we know that it has a low PED value relative to the other good, meaning that it's more inelastic. So there is a small amount of responsiveness to demand in a change in price. And for good K, we know that it's a manufactured good, which usually we can assume it is that it usually has a higher PED value, therefore it's more elastic. So primary products like good J have less substitutes, therefore PED is more elastic since there is a low level of responsiveness for demand, meaning it's more inelastic. On the other hand, manufactured goods like good K have more substitutes, so demand is elastic, which means that it's very so the demand of it is very responsive if there were to be a change in price. Thank you for watching.